All right, so this is our stochastic models project. My name is Alberto.
My name's Anthony.
My name is Juan.
My name's Emily. So for our project, our goal was to identify and collect the data from 100 students and determine the relationship between the hours worked each week and a student's GPA. We analyzed our data using the descriptive analysis process while we tried to find a correlation in the data, and each group member then developed a hypothesis and tested it. We collected our data by presenting a Google form to both STEM and non-STEM students from varying points in their degree. We asked them how many hours they worked each week at their jobs and what their GPA is. From this, we were able to gather 100 responses that varied significantly in terms of number of hours worked and the corresponding GPA. This is the result of a poll we conducted of the 100 students who do and do not work jobs while attending college. The first column indicates how many hours each week the student works at their job, and the second column is the student's current GPA. These students were studying at various colleges around the DFW area. We are showing a graph with a trend line. The GPA is the y-axis and the hours worked per week is the x-axis. Here's a quick view of our data in forms of a bar chart and box plot. These graphs were calculated in Excel and show a quick representation of the correlation between hours worked per week and their GPA. This is our descriptive analysis that was completed using Excel. The mean for the hours worked per week was 19.55 with a standard deviation of 11.91. The mean for GPA was 3.165 with a standard deviation of 0.47. For my hypothesis, I tested whether a student working 15 hours or less a week will have an impact on the student's GPA. For my null hypothesis, I wanted to see if 15 hours or less working each week will have no impact on the student's GPA. My alternative hypothesis is that working 15 hours or less per week will have a positive impact on a student's GPA. To start my testing, I ran calculations from the original 100 student poll, but removed the y variables that were greater than 15 hours worked per week. This reduced my sample size, which is represented as N, to 25 students. From here, I began my descriptive analysis calculations using Excel. I began by calculating the mean, median, mode, and range of the data for both hours worked and the GPA that was correlated. Next, I calculated the standard deviation by subtracting the mean from each score, squared each deviation, added in the square deviations, divided that sum by 25, and then took the square root of that result. I then calculated the sample variance by finding each data point's difference from the mean value, squared each value, and then added them all up, then divided by that sum by n minus 1. The skewness was calculated by subtracting the mode from the mean and then dividing the difference by the standard deviation. I then used the z-test to calculate the z-score and determine whether or not the null hypothesis was accepted. I calculated the z-score by subtracting the mean from the sample size, then divided the difference between by the standard deviation. My result was negative 35.2592, which is less than the critical value of 1.782. Due to my z-score being less than the critical value, my null hypothesis of working 15 hours or less per week will have no impact on a student's GPA is rejected. Therefore, I accepted my alternative hypothesis that working 15 hours or less per week will have a positive impact on a student's GPA.
For my hypothesis, I tested to see if students who worked between 15 and 30 hours per week had a higher GPA. For my null hypothesis, I wanted to see if there was first any correlation at all between a student's GPA and the amount of hours worked in a week. My alternative hypothesis was that students who work between 15 and 30 hours a week had a higher GPA. My process for testing my hypothesis was practically the same as Emily. My sample size was 60. My sample size was 63, since that was the amount of students that worked between 15 to 30 hours a week. Using Excel, I was able to find all the calculations that I needed. For example, the mean, the median, the mode, standard of error, standard deviation, and other values as well. After that, I calculated the z-score by subtracting the mean minus the sample size, then divided the difference by the standard deviation. My z-score was negative 0.47, and then compared it to our critical value, 1.782, which showed that the z-score is lesser than our critical value. Therefore, my null hypothesis then rejected. And then we move on to our alternative hypothesis, which we ended up accepting.
My hypothesis testing is seeing if the data provided strong enough evidence to conclude if the average GPA for students who work is larger than 0.2 points than those who do not work. Since I am dealing with two different sets of data and both contain the sample size, sample mean, and sample standard deviation, I knew I was dealing with the t-test. First, I set up my null statement, which is HO, being mu1 minus mu2 is equal to 0.2, where mu1 and mu2 is the population mean for both sets of data. For my rejection statement, which is H1, I got mu1 minus mu2 is greater than 0.2. From there, I needed to find my t-value. First, I need to find the SP value, which is used within the equation to find t. The equation is to find SP is the square root of the sample size of the number of students who do not work minus 1 times the standard deviation of the data set squared, plus the sample size of the data set of students who don't work minus 1 times the standard deviation of the data set squared all over the entire sample size minus 2. This gives us an SP value equaling 0.474186. Next, we use the value as well as the sample means and sample sizes to find our t-value. To find the t, we take the sample mean of students who do work minus the sample mean of the students who do not work, and then divide all that by SP times the square root of 1 divided by the sample size of students who do work plus 1 divided by the sample size of students who do not work. This can be seen from the second equation on this slide. This all gives us a value of 0.792163 for t. Then I used a significant level of 0.05 to find our t value. Using the table, I found that the t star value comes out to being 1.645. Drawing our curve as seen in the image on this slide, we see that the t star value is greater than the t value we found. This means our t value does not fall in the rejection zone and we fail to reject H naught.
Just a quick recap of linear regression if you're not familiar with the term. Regression is one of the most widely used predictive and modeling techniques used in anywhere in the world, and this pretty much makes it imperative that you know enough to be conversant in the topic. This method used has a variable being described, which is the dependent variable, or also known as y, and the variable used to describe, which is the independent variable, also known as x. Into this presentation, our independent variable is also hours worked per week, with our dependent variable being the GPA. In order to have a valid regression, we need to point out that we need valid assumptions. With that said, the first point is that the error has to be random. For the following point, the error has to be normally distributed within the data. For the third point, the variance of error has to be constant. And as for the last point, there can be no autocorrelations within the graph. Using the data from the Google form and the tools from Excel, we obtain the following results for the line regression. The first statistic from the regression is multiple R, which can be also known as correlation. We can see that our value for correlation is 0.194652. The following value can be obtained by squaring multiple R, but essentially the R squared value actually tells us how well the model fits our data, which means only 3.8% of variation in GPA can be predicted from variation of hours worked. I suppose many of you are familiar with the term standard error, but if you're not, it just simply means that the error with the measurements taken from a sample. As for observations, they can be identified as the number of entries in our Google form, which is 100 minus 1 or 99. With the ANOVA table, it includes more sophisticated technical statistics that undermine the errors by the regression line. As for the lower table entry, it describes the linear model that will graph a best fit line through the data.
Our results from our hypothesis test show that there is a correlation between hours worked per week and the student's GPA. The first hypothesis shows that the students who work 15 hours or less have a higher GPA. The second hypothesis shows that the students who work 15 to 30 hours per week have a higher GPA than the students who work less than 15 hours or more than 30 hours. And the third hypothesis shows that people who work have a higher GPA than people who do not at all. Our hypotheses show different results and a weak correlation, but overall show that people who work have a higher GPA than people who do not work at all.
Overall, we focused to see if the amount of hours worked per week correlated with the GPA of students from several universities around the DFW area. We collected 100 surveys that told us the amount of hours students worked and their GPA. With the data collected, we found that working while going to school does improve your GPA. We found that when students work less than 30 hours a week, tend to have a better GPA than those who work more than 30 hours a week.